All right, welcome to the Explainer. Today we're diving headfirst into a question that, well, it really cuts to the very heart of reality itself. It's a profound challenge to one of the most exciting new ideas in all of physics. So get this, the source material for today's Explainer doesn't really ease you in. Nope, it just throws down a gauntlet. It puts forward a single, powerful question that's designed to stop an entire field of theoretical physics dead in its tracks. And look, this isn't some tiny, nitpicky academic debate we're talking about here. This is a huge disagreement over what the universe is actually made of at its most fundamental level. I mean, for centuries, we've had a pretty solid idea, right? But now, a new contender has stepped into the ring. And honestly, it could change absolutely everything we thought we knew. Okay, so on one hand, you've got the view we all probably learned in school, right? The universe is made of stuff, matter, energy, and it all follows the laws of physics. Simple enough. But on the other hand, you've got this wild new idea that the universe is fundamentally made of information. Yeah, you heard that right. And the laws of physics, they just kind of emerge from that underlying code. So what does that even mean? The universe is made of information? Let's break that down a little bit. The easiest way to think about it is like we're in a giant cosmic computer simulation. In this model, the most basic layer of reality isn't a particle or a wave. It's a bit of information, a simple yes or no, a 1 or a 0. And everything we see, touch, and experience, that's all just the output of this unbelievable, massive calculation. I know, it's a totally fascinating, mind-bending idea, but it runs smack into a very big, very solid problem. A problem that, according to our source, the people who back this theory have a really tough time answering. And that right there brings us to the absolute core of today's Explainer. We've finally arrived at the mystery, the one killer question that's at the heart of this entire debate. And there it is. That's the challenge, laid out plain and simple. It sounds so easy, doesn't it? But it is devastatingly complex. Just let that sink in for a second. How do you make a physical particle, a piece of matter, out of nothing but abstract information? And here's the real kicker. The source claims that when you pose this question to the information-first folks, you don't get answers. You get avoidance. It's the one puzzle they supposedly just can't solve. Okay, so to really get why this question has so much punch, we have to understand its most important word. What on earth is a fermion? And why is it such a huge problem for this new theory? All right, let's put on our detective hats and investigate the star of our show, the fermion. To put it simply, fermions are the stuff that stuff is made of. We're talking protons, neutrons, electrons. Literally the building blocks of every single atom in your body, in the chair you're sitting on, in everything you can see and touch. They're all fermions. A great way to think about them is as these fundamental, indivisible Lego bricks of reality. You can't build a fermion from smaller pieces. It just is. And these Lego bricks, oh man, they follow some very, very strict rules. So what are these rules? Well, first, like we said, they're the building blocks of matter. They've also got this weird quantum property called spin. But the big one, the one that's absolutely crucial for this whole discussion, is something called the Pauli exclusion principle. It basically says that no two identical fermions can be in the exact same state at the exact same time. Period. And why should you care about that? Because that single rule is the reason your hand doesn't just pass straight through your desk. It's why atoms have any structure at all and why matter takes up space. It is the very reason for solidity itself. These aren't just suggestions, they are non-negotiable laws of the universe. Okay, so let's bring it all back home, back to the central conflict. Now that we know what a fermion is and how stubborn its rules are, we can really see why it poses such a massive challenge. Here's the whole problem in a nutshell. Information by its nature is abstract, it's flexible. But the rules that govern fermions, they are rigid, absolute, and totally unbending. So how in the world does one create the other? How does a flexible, abstract code give rise to a fundamental physical law that basically says, nope, you shall not pass? You see, getting a system made of pure information to spit out not just any particle, but a particle that is forced to obey these incredibly specific, almost personality-like exclusion rules, that's a hurdle that so far no one has been able to clear. The math just doesn't seem to get there. Not yet, anyway. And that really is the bottom line here. If you're going to propose a theory of everything, it can't just explain the cool, elegant parts, like gravity or space-time. It has to be able to explain everything. And that includes the gritty, fundamental, rule-bound nature of matter itself. It has to explain the fermion. Which kind of leads us to our final big thought for today. The fermion, with its stubborn, unsimulatable existence, seems to suggest that maybe, just maybe, there's something more to our universe, something deeply physical and fundamental that just can't be boiled down to a simple string of ones and zeros. So, what do you think?